Hi all. So welcome to the course EC312 Object-Oriented Programming. So we are looking at module 5 Android programming of the course EC312 the Object-Oriented Programming. This is the first lecture. In the first lecture we are going to introduce Android. So we'll be going through the evolution of the Android, what are its main features and what is the basic architecture of the Android. So when you introduce Android, as you all know, that it is an open source mobile operating system. So what is an open source mobile operating system? Open source means the source code or the code in which the Android is written is open to everyone. So anybody can access the code, anybody can modify the code, and anybody can develop their own applications based on the Android code. And it is an operating system which is basically an OS, just like Windows or Linux, but mostly works in embedded domain. It is developed by Google. So Google is the pioneer in developing the Android, and since it has started the development, we have seen a sharp rise in the number of mobile applications based on Android. Not even mobile, you can see tabs, watches, TVs, etc., which runs on Android. And it is based on Linux kernel, and it is designed primarily for touchscreen mobile devices such as smartphones and tablets. So you need to see that it is the basic stuff in the Android is basically the Linux kernel. And kernel is something like you can say like a brain of any operating system. So Linux kernel is which is the core part in the Linux, and the main functionalities of Linux kernel includes the drivers like Wi-Fi, keyboard drivers, etc. So basically you will be able to interact with any of the hardware. And Android is the most successful, powerful mobile operating system in the market today. That you can see that looking at the number of Android Android apps and Android devices. Now we have millions of Android devices. So it is the most successful and widely used operating system in the market today. So why do you want to go with Android? So what are the features which makes Android so much popular? The first and foremost being it is an open source. So open source, as I said earlier, so anybody can take out the code, they can modify the code, and they can develop from the code. Unlike Windows. So Windows is not an open source operating system, and you want to you can't take the source code of the Windows operating system and modify it because it is proprietary to Microsoft, and only Microsoft employees or Microsoft development teams can use the code. So there is some restrictions on who can use the code, while Android is an open source, which means anybody can use. And the second and most important thing is it is customizable operating system. Customizable in the sense like you can delete some portions of Android and add your portions. So what you want to achieve, you can do with the Android operating system. It is of reduced complexity of development, and it reduces cost of development, and it is reduced overall complexity. Another important feature is there's a large community and developer reach. So this community part is important in the case of any kind of development, because the more number of communities you have, then there is more number of interactions within the community, and which brings out new and new ideas, which brings out new and new features, and it has a higher developer reach also. Like a lot of people are working on Android to make it much better. There is inter-app integration and higher success ratio. So if you look at the number of Android, if you just look at the number of Android devices we have, you can see that there are millions and millions of devices, which means it's higher. Because of the success of these devices, more and more devices are coming out, the higher success ratio, and there's a rich development environment. So development environment is one in which somebody need to, if somebody wants to develop an application or even the OS itself, then you should have that environment in which you should be able to develop it easily, like for example an IDE or the compiler, the builder, assembler, etc. If they are available easily, and if you can and if it is easy to study and use them, then it will be having a rich development environment. So let's look at the evolution of Android. So if you look at the names that we have till now, you can see that the Android usually goes in alphabetical order, except for the first version, which is 1.0 and 1.1, and then it came Cupcake C, Donut D, Eclair, Froyo, Gingerbird, Honeycomb, Ice Cream, Jelly Bean, Kit Kat, Lollipop, Marshmallow, Note, and we have now till Pi, Oreo and Pi. But if you look at the sequence, you can see that it always goes in the first letter will be according to the alphabetical order, and most of them are names of some kind of any chocolates or sweet items. Among them, the Jelly Bean is considered as one of the important update in Android, because that has changed many things which were till then, which was evolved. So it's like a major part of the evolution, the Jelly Bean. So what are the features in Android which makes it unique when compared to other operating system? The first and foremost feature obviously is the beautiful UI. So UI means that whatever user interface. So UI is user interface, which is basically whatever you see on the screen. So in Android, you see on the screen, you can see that it's easy it's a touch. Android means like you can always scroll using your fingers, you can click and open an app, and inside the app you can have different menu options. So those are very user friendly and it's aesthetically very pleasing. So that's a beautiful UI. And there another thing is like connectivity. So you can connect your Android with a Bluetooth, Wi-Fi, LTE network, NFC means near field communication, WiMAX. So there are n number of connectivity options you have, and you will have good storage. Media support means like which all files can you run in an Android device. So there are lot of number of file formats or codecs in video and audio, and many different OSs doesn't support everything, but Android support a large number of available media file formats like MPEG-4, high resolution, H.263, H.264, MP3 for audio, WAV, and for images JPG, PNG, GIF, and BMP. Similarly, you can send messaging, you can use SMS or an MMS. Web browser, almost all of the web browsers that we use in Windows are supported in Android, like you can use Firefox or Chrome, and those are all even running in the latest technology like HTML5 and CSS3. Android also supports multi-touch, like you can use a single finger to scroll and everything, but if you want to enlarge an image, you can just use two fingers and swipe across. So that means it can support multi-touch. And it started with the HTC Hero Mobile, and then you can see that it also supports multitasking. So multitasking means you can open Facebook, then before closing that Facebook, you can also open WhatsApp. So Facebook will go in the background, WhatsApp will come in the foreground, but Facebook will be still running at the background. So you can say that you can have any number of tasks running in the background, which is basically, and you can just swipe back to Facebook and WhatsApp using a single touch. So those are like multitasking tasks. There are widgets, like for example when you open Android phone, you can see that there is a clock or weather etc on your front screen. So those are called as widgets, and you can resize the widget, and you can expand and show more content. Also you can have multi-language, like English is the normal language which is being used in every Android thing, but you can see that you can also have many of the Indian languages like Hindi, Tamil, Telugu, etc. in Android, and even the language that we use in writing, like English is a left to right language where you start from left and goes towards right, but you can also have Android with Arabic, in which it starts from right and goes to the left. So it can always support a bidirectional test. Now GCM is a feature in which it is called as a Google Cloud Messaging service that lets developers send short messages data to their users on Android devices without needing a proprietary sync solution. So you can directly send a message to an Android device without having to go via the server. Wi-Fi Direct, like technology that lets apps discover pair directly or a high bandwidth peer-to-peer communication. You can put your Android devices face to face and you can send data. Android Beam is a popular NFC technology. NFC, as I told earlier, it is basically a technology, near field communication technology, where if your mobile is in the vicinity of the field of the communication, then you can always exchange messages. So these are the features which enables Android to be one of the best operating systems in the world. So let's look at some categories of applications that we have in Android. The first and foremost, like if you look at even the Google Play Store, you can see that there will be a category for entertainment, you can have Netflix, Prime Video, all this entertainment stuff. You will have tool category like antivirus scanner, booster for your mobile. You will have communication categories like messaging category. WhatsApp will comes in the communication category. You can have phone calls, etc. Productivity, like Office stuff, Microsoft Office, or those things are called as productivity. You can have Word, Excel, etc. in your Android. And you can have personalization, like if you want to make your Android phone with good wallpapers, good backgrounds, you can do that. Music and audio, again, if I Ghana, Raga, extra different music applications that you are available in Android. Social media and video, that is Facebook, WhatsApp, etc. social media applications. And travel, like Make My Trip, Clear Trip, etc. IRCTC is another one, and almost all the local governments have their own apps for buses, timings, etc. So this almost all possible Android applications are available in the Google Store, and the variety of these applications is because of there are a lot of people who are developing the Android because of the popularity of Android, that in turn contributes to more popularity to the operating system. So the popularity of an operating system can always be calculated using the number of applications available to that. So Android and iOS are the most popular operating systems available for the mobile market. So let's look at the architecture of the Android. So Android architecture consists of, so architecture means like how the operating system is written or programmed or is available for others to develop. So this architecture will not change for a long period of time. So this is a fixed architecture and nobody is allowed to alter this architecture. So there are different layers on our architecture. The bottommost layer is called as Linux kernel. We'll see what are all functionalities of Linux kernel. And Linux kernel will be interacting with libraries and runtime libraries. above libraries and runtime, you have application framework, and application framework will interact with libraries and runtime. And above application framework, you have application, and application will interact with application framework, and applications are used by users. So users, when you do or open an application, it will go to this application layer. It will, for example, open something. Then let's say the user wants to send a message using WhatsApp. Then the user types whatever the message to be there in WhatsApp. So this message will be passed to the application framework layer, which will pass to the libraries to get useful information. Then it will go to the Linux kernel for transfer, because the Wi-Fi driver will be there in the Linux kernel. So it will be given to the Wi-Fi driver, which will transfer the required information. So let's look at first the Linux kernel. So if you look at the Linux kernel, you can see there are multiple layers in Linux kernel. Then like mostly all of them, or almost all of them, are driver. So this is a display driver, camera driver, Bluetooth driver, flash memory driver, binder, keypad, USB, Wi-Fi, audio, power management. So almost all the drivers and the power management comes in the Linux. Now Linux kernel might not need to have all these modules. It is customizable, means that you can delete some of these drivers which you don't need. For example, if your Android phone doesn't have a Bluetooth, you can just remove this Bluetooth driver and you can customize this Linux kernel. And so all these layers, all these modules are different modules in Linux kernel which will interact with the upper layers. So Linux kernel is the bottommost layer in the architecture of Android, and it never interacts with the user. So Linux kernel is the bottommost layer, the user layer is here, and user only interacts with the application. So user doesn't need to, actually the application indirectly interacts with Linux kernel, but the user doesn't need to interact with the Linux kernel directly. Okay, so Linux kernel will not direct interact with the users, but it is the heart of the whole system. Now, because of the Linux kernel, it provides a level of abstraction between the device and hardware. Abstraction means something which is being hidden. So between the device hardware, so basically whatever is above the Linux kernel, libraries, application framework, etc., these are like software part. And you can see that there is some kind of a hardware which sits underneath it. So Linux kernel, which provides an abstraction, like Linux kernel hides the hardware from all other layers. So Linux kernel provides a abstraction for the hardware. And also kernel handles all the things that Linux is really good at, such as networking, device drivers, and interfacing to peripheral hardware. So all the interfacing and the networking is done in the Linux kernel. So next layer is library. So libraries carry a set of instructions to guide the device and to handle different types of data. So there are different modules in library: Surface Manager, Media Framework, SQLite, libc, SSL, FreeType, OpenGL, SGL. So these are like standard libraries in any operating systems, and you can have these libraries in Android also. So on top of the Linux kernel, there are a set of libraries including open source web browser engine, WebKit, known as libc, SQLite database, useful for repository for storage and sharing of application data, libraries to play and record audio and video, SSL libraries responsible for internet security. So SSL libraries are like for internet security, SQLite database are for database handling, and there are other libraries for storing data, etc. in the library section. So libraries also play an important part in giving the user what he or she wants. Apart from these standard libraries, there are some Android libraries also present in the library. So these Android libraries are Java based libraries. So you can write the Android application either in Kotlin, which is a language, or in Java. So the Linux kernel is basically mostly written in C, and libraries are mostly written in CPP. But you can also have Android libraries which is written in Java in this library module. So if you are a developer, not an application developer but an Android developer, then you can write your own Android libraries which will help any application developer to interact with the Linux kernel easily. So examples of libraries include application framework libraries in addition to interface, graphic storing and database libraries. So I am listing some good amount of libraries available in Android. So this is just for your information. Like, you can have large number of libraries ranging from user interaction till advanced communication. So these are some of the libraries which are used in Android. Now there is a small portion along with libraries which is called as a runtime. Just like in Java we have JVM, which is Java Virtual Machine, which converts the bytecode and run the bytecode, which is basically the interpreter in Java. Similar to that, we have something called as Dalvik Virtual Machine. It's a kind of JVM designed and optimized for Android. So whatever application you write, it will be converted to some kind of a bytecode, and it will be interpreted using this Dalvik Virtual Machine. And it enables every Android application to run its own process with its own instance of Dalvik Virtual Machine. So Dalvik Virtual Machine is purely for this Android, so that each application can be run as a separate process, which can be interpreted only by the Dalvik DVM. The Android Runtime also provides a set of core libraries which enable Android application developers to write Android applications using standard Java programming language. So that's a very important part, because Java has been, before the starting of Android, Java was the main language in developing many of the mobile applications. Once Android came into picture, then most of the Java developers would like to do their Android development in Java because they are very well versed in Java. So Android provided an option in which you can write your Android application in Java. So this Java program will be interpreted in this runtime DVM, and which can be used to do the necessary task. So that's a very important advantage of Android development, because you can write the Android applications in Java also. Next layer is application framework. So it is the one which will be interacting with the application, direct interaction. Mostly if you look at application framework, those are like manager layers. So there is an activity manager, window manager, resource manager, package manager, telephony manager, location manager, view system. If you remove the manager, you can see that most are application, like activities in application, window application, package application, telephony application, location application. So these are all applications, and this application can be managed using the manager. So it provides a many high-level series of applications in the form of Java class. The Android framework includes the following. So the framework includes some of the key services. First one is called as activity manager, controls aspects of application lifecycle and activity tasks. So we'll go in detail to all these things at the later point of other lectures. There is content providers. So there will be many applications which will be running in Android. So if you have two applications running in Android, then there should be some mechanism in which you should be able to share the information. For example, there is one application in which there is a gallery in Android, and then you have WhatsApp. Now you want to share some data from gallery to WhatsApp. So how will you do that? So those all things come into picture when we develop the Android thing. So these are all taken care of by content providers. Similarly, there is a resource manager, so access to known code members, resources such as strings, card settings, and user interface layout. And then we have a notifications manager, so it allows applications to display alerts and notifications to the user. View system, an extensible set of views used to create application user interface. So you in your Android phone, you might receive notifications at your top bar. Now who will manage these notifications, and who is the one which is saying that okay, this should be notified and this should not be notified? So there is a notification manager which will manage all these things. So this notification manager which sits in the application framework. The last and most important is the application itself. So applications are a topmost layer of Android stack, and the user interacts with applications directly. And applications can come from a simple alarm clock to complicated media and video applications, browsers, instant messaging, calendar, email, SMS, contacts, voice, home, all this, calculator, all this can be any kind of application. Anybody can develop an application over the Android stack. So this application will be installed in this application layer, and the application has many components. The first and foremost is the activity. So if you look at an Android phone and open an application, it will open a window. So that window is called as an activity, and inside that window you can change many things, like you can click another button and it will move to another window. So all these windows come into this activity. And there are services. So whatever you do in this application, there is a background service which is running, which tells the other layers what to do. There are broadcast receivers. So this application might be communicating with other applications, and so that is controlled by broadcast receivers. There is content providers, so they handle the data management. So as I said earlier, if you want to share something in your WhatsApp from the gallery, so you have this content provider in your application which will handle this. So these are all these different components in the applications, which is very important. So we'll all go through each of these in the future lecture. So these are some of the references from which I have taken the today's slides, and you can go through these references for more information. Thank you.